Okay, so for the distance the ball travels, the ball starts at 4 feet and it moves up to 20 feet. And it's starting at 4 feet, you take 4 feet, 20, and that makes it 16. Then also the ball is traveling down 16 feet, and that would make it 32 feet for the distance the ball travels.
Okay, pause. Does everybody understand why it's 32 feet, the distance the ball travels, the total distance? Very good. Awesome. Continue to explain.
Okay, and then the ball travels up for 1 second because it stops at 1 second and starts going down after 1 second.
Very good. You're absolutely correct. Good. So go ahead and give one of these to everybody in your group. Thank you. Perfect. Okay, so now, any questions on that?
Yeah, did we not get it right then?
You got it right. It was the best explanation. Your explanation was great. My favorite was personally that explanation. But so Braylon, your explanation was great too. It was absolutely right. Just different than theirs. So, very good. All right, any questions on this? Okay, so let's answer just out loud, guys. Stay with me here. Same question. I'm just going to ask you some more questions. They should be pretty easy for you now. At what height do you release and catch the ball?
4.
4 feet. Very good. Any questions on why it's 4 feet? I need you all looking at me. How many seconds is the ball in the air?
2.
How many seconds is the ball in the air? 2 seconds, right? Very good. So it travels up for a second, down for a second. So that would be 2 seconds. What is the y-coordinate of the vertex of the parabola? So Justin says 20. So Justin, is this a maximum or minimum value? Max, that's our vertex right here. Okay, so the y-coordinate of the vertex is?
120.
Over 1 up 20. So Justin, you were right. Our y-coordinate of the vertex is 20 feet. Are you guys following me? I can't tell. Some of you are kind of zoning out. Are we all good?
Why did you say y-coordinate and just...
It was just a question. So I could have said, what's the x-coordinate? Does that make sense? So it's just getting you to think.
But if it's the x-coordinate, we just put the x-coordinate.
Yeah, we just put 1. So this one said, what's the y-coordinate? So that's why we just answered this one as 20. Good question. How many feet has the ball traveled when it gets to its maximum value? How many? So I'm going to read that again. How many feet has the ball traveled when it gets to its maximum value? Isn't that from here up to here? So that is 16 feet. Any questions on that? Okay, moving on. All right, good job, guys. That was good. We were able to apply quadratics in the real world without even really getting a lesson on that. So good. Okay, so recall, yesterday we got introduced into quadratics. Remember, quadratics are a symmetric U shape. We have two different types of quadratics. A U that faces upwards and a nice symmetric U that faces down. So anybody, can you tell me, when will this face up?
Positive.
If what's positive? Very good. We have quadratics of the form ax squared plus bx plus c. And if our a value is positive, then it is, it's a smiley face, right? Positive people smile. Remember we talked about that yesterday. If a is negative, sorry, I'm going to change here. So if it's positive, it's going to be a U, a smiley face. And if a is negative, it's a frowny face, right, everybody? Okay, so tell me, what is, okay, I want you to tell your group people, what is the vertex? Ready, set, go. Okay, I heard exactly what I wanted to hear. The highest point or lowest point. Is this a high or low? Is this a max or min? It's a min. Is this a max or min? It's a max. Very good. Any questions on that? Okay, I need you to tell your group, what is the axis of symmetry? What does it entail in a parabola? Or what's it used for? Or whatever. Okay, I like Braylon's answer. Braylon, what did you say? The axis of symmetry is what?
If you fold it in half, it's the same.
Okay, so along the axis of symmetry, if you fold it, it's going to be the same on both sides. Love it. What's another thing for axis of symmetry? It's going to fall on the...
Y.
It's going to fall on the vertex. So isn't this going to be our axis of symmetry?
Okay.
Isn't this going to be our axis of symmetry? Okay, awesome. So does anybody else have anything that they can say about the axis of symmetry? It's symmetric about it, right? So we've kind of said it all. Okay, good. Okay, so recall that yesterday we were dealing with quadratics of these forms. Y equals ax squared and y equals ax squared plus c. So, if we have y equals ax squared, we're missing, so first of all, remember quadratics in general have the form ax squared plus bx plus c. Yesterday we were missing bx, or we were missing bx and c. So right here we were just looking at ax squared. So remember that if it had this form, our vertex was at 0, 0, right?
Right.
And then we learned that, okay, if we have y equals ax squared plus c, it's the same thing as this, it's just been shifted up or down the c value, right? Okay, so wouldn't our vertex be at still 0, up or down c? Yeah? Because it's just shifted? Okay, so what's my vertex on y equals x squared? 0, 0. It has the form y equals ax squared. Very good. And what's my vertex on y equals x squared plus 3? 0, comma, what? 3. Good. So does everybody see how these two things relate? Well, quadratics oftentimes have a bx value. In fact, most of the time they have a bx value. So we have to be able to know how to do those. So understand this. This is what today's lesson's on. A quadratic function of the form y equals ax squared plus bx plus c. The b value affects the position of the axis of symmetry. So I'm going to say it again. The b value in front of x affects the axis of symmetry. So consider these three graphs. So we have y equals 2x squared plus 2x. Does everybody see how my axis of symmetry has shifted?
Yes.
So now it's moved. It's not at the y-axis. 2x squared plus 4x. Do you see how the axis of symmetry has moved this way? Shifted, right?
That's it. Down to.
We're gonna talk about it why in just a second, like how to get the axis of symmetry. But I'm just right now my point is, do you see how the axis of symmetry has been shifted? Okay, so that's all we're getting at right here. Do you see how the axis, because we have 2x squared plus 6x, do you see how the axis of symmetry has been shifted? Okay, so now I'm going to tell you how to know exactly where the axis of symmetry goes. This is what you want to write down, this formula. So really, no matter what, you can use this formula. Really, you can graph any quadratic this way. Even the stuff we learned yesterday, you can use this method to graph any quadratic. So the graph of, just a second, I have to make sure the office isn't calling me. Okay, so the graph of y equals ax squared plus bx plus c, where a does not equal 0, has the line x is equal to negative b over 2 times a. There's our formula. That is the formula for the axis of symmetry. So we can always find, given a quadratic, the axis of symmetry. So once again, the formula is x is equal to negative b all over 2 times a. Now remember, where b and a come from is from the quadratic equation here. A is in front of x squared, very important. B is in front of x, very important, and c is our constant. Is everybody comfortable with that? All right, so that's how you find the axis of symmetry, even for graphs we were doing yesterday. So now before we get to this piece, I want you to know the steps to graphing a quadratic. I expect to see these 4 steps on your paper with, like, your work. Okay, so these are the steps to graphing a quadratic. First, you must find the axis of symmetry using this formula. X equals negative b divided by 2a. Now, negative b just means the opposite of b as well. Keep that in mind. Once you've found the axis of symmetry, you'll draw it in. So there's our axis of symmetry. Well, think about it, guys. Isn't our vertex always on the axis of symmetry? Yes. So our vertex is going to be on the axis of symmetry. So if you know the axis of symmetry, you know the x value or the axis of symmetry, because it's going to be on the axis of symmetry. Well, you don't know how far up or down to go. But if you know x, can't you find y? Can anyone tell me how? How do you find the output of a function at a certain value? If we know x, how do we find y? Yes?
You plug in the y, the 0. Oh, that one thing, y/x over.
Good. Yes, absolutely. So Brendan says if you know x, then you can find the function at x, right? By plugging in that value into our function wherever there's an x. Does everybody get what I'm saying here? So to find the xy point, you'll know x because it'll be on the axis of symmetry. You'll plug in that value, and that will give you your y value. So let's say you plugged in 2, because your axis of symmetry is at 2, and you get the answer of 3. Then your answer will be 2 up 3. So you'll put your vertex. So once you've plotted your vertex, then the third thing you'll do is plot the y-intercept. The y-intercept is always, 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 no matter the function, quadratics, linears, exponentials, any function, the y-intercept means where it's crossing the y-axis, and it's always, always, always when x is equal to 0. So if you want to know where the function is when x is equal to 0, you'll plug in 0 into your function. So that's what this is saying. So if you want to know the y-intercept where it's crossing the y-axis, you'll plug in 0 for x into the equation. So let's look at it, guys. If we plug in 0, and we will have a times 0 squared plus b times 0 plus c, right? Yeah? Isn't 0 squared 0?
Yeah.
0 times a is?
0.
0. So we have 0 plus b times 0. Isn't that 0 plus 0?
Yeah.
So then we have 0 plus 0 plus c. So what's our y-intercept always going to be?
C.
C. So does that make it easy for you? Do you understand what I'm saying here? So it's always when x is equal to 0. You plug in 0, you're always going to get c, right? Okay. So you'll find the y-intercept. So you'll plot the y-intercept. That's your third step. And fourth, you'll find 2 other points on the graph. So any other 2 points you can find, and then you know it maps evenly across the axis of symmetry, and then you can graph it. And we'll just use our calculator like we did yesterday to use whole number points, so we don't have to calculate them, so we can do it quickly. Okay, let's practice this. Are you ready to practice?
Sure.
Okay, here's my first example. So, pay close attention. For some reason, this was super hard for first hour, and I have no idea why. You follow the steps, period, end of story. So I need you to all pay close attention, please. So it says, what is the graph of the function y equals x squared minus 6x plus 4? My first step, follow the step-by-step instructions, and then pretty soon you'll just know them. And you'll use them every time. What's my first step? Find the axis of symmetry. So we use the formula x equals
Positive C.
negative b over 2a. That's the formula you have to have memorized to find the axis of symmetry. Does everybody understand how to find the axis of symmetry? You use that formula. Yes.
Would that 6 be positive then?
Yes. So now we're going to go through. Let's list out our a value. What's a?
Negative 6. I mean x.
A is in front of x squared, guys. What is a?
1.
What's b? B is in front of x.
Negative 6.
Negative 6. And c is?
4.
4. Guys, if you're going to go this slow, you're going to have so much homework. So you need to all start paying, helping me out here. Okay, so to find the axis of symmetry, we're plugging in b and a. So we have x is equal to the opposite of b. So the opposite of negative 6, which is?
6.
So 6 over 2 times a. A is?
1.
So what we have here is 6 divided by, which is equal to?
3.
So x is equal to 3 is our axis of symmetry. So find that value, x is equal to 3, and draw in your axis of symmetry. You've done your first step. Now, we have a parabola that's going to be symmetric around the axis of symmetry now. Second step. What do we do second step? Plot the vertex. So to find the vertex, do we know it's going to be somewhere on the red dotted line?
Yep.
So what x value is it going to be at?
3.
3. So we know that the vertex is a point. 3 comma question mark, right? We don't know how far up or down to go. Well, to know what your function is at 3, you literally plug in 3 into the function. You all understand that, right? Mm-hmm. Okay, so I'm going to plug it in. I am telling you, you have to use parentheses. You have to use parentheses, guys. If you do not, you're going to get it wrong. So I'm plugging in 3 wherever there's an x. So I have 3 squared minus 6 times 3. Wherever you're substituting, you put a parentheses. Plus 4. You even need to type it in your calculator that way. So we're going to have 9 minus 18 plus 4. Is everybody following me? And you get negative 5. So our vertex is at 3 comma negative 5. So now I'll plot my vertex. Over 3, down 5. So now this is the size of the point. But can anyone tell me if this is a smiley face or frowny face? Why do you say smiley face?
Because A is 1.
Good. A is 1, so it's positive, right? So it's going to be a smiley face. Very good. Number 3, third step is to find the y-intercept. That's always when x is equal to?
0.
When x is equal to 0. So let's plug that in. We're going to have 0 squared minus 6 times 0 plus 4. Isn't that going to be 0 minus 0 plus 4? So it is. So it's crossing the y-axis. Our y-intercept is at 4. Sorry, 4. So our y-intercept is at 0, comma 4. So over 0, up 4. It's crossing the y-axis right there. Now our fourth step is to find 2 other points. So 2 other points, I'm going to ask you to graph this in your graphing calculator and then give me 2 whole number points. Any 2 whole number points. So we're to our fourth step. Give me 2 more points. Quick. Alright, so I'm going to plot those 2 points. 1, so over 1, down 1. And I'm plotting also over 2, down negative 4. Okay, so now those points on the left, so we have this side of our parabola, don't they map evenly to the other side of the axis of symmetry? So make sure you're doing that across the axis of symmetry, not the y-axis. So this is over from the axis of symmetry 1, 2, 3, so I'm going over 1, 2, 3. This is from the axis of symmetry 1, 2, so I'm going 1, 2. From the axis of symmetry, this is 1, so I'm going 1. So I can draw in my parabola. Are we all okay so far? Now I'm going to find domain and range. That's our last step, because I'm requiring you to do that. So what's the domain? It doesn't matter that my function's growing up. Left to right, where's my function growing? All real numbers. Negative infinity to positive infinity, right? What's my range? Range is y values. You always start with the smallest y value to the highest. Negative 5 to? Positive infinity. Does it include negative 5? Alright, so is everybody good with that? Okay, let's go through this next example 10 times quicker, how about? So let's all help me out. Y equals negative x squared plus 4x minus 2. Our first step is to find the axis of symmetry. X equals negative b divided by 2 times a. A in this one is negative 1. B in this one is 4, and C is negative 2. Awesome. So, plugging it in, x is equal to the opposite of b. So, negative 4 divided by 2 times a is negative 1. So, on top we have negative 4, on bottom we have negative 2, which is 2. X is equal to 2. Our axis of symmetry is at 2. Draw it in. Okay, from there, second step is to find the vertex. To find the vertex, you know if the x value is 2, to find this part, you plug it in. So now this is where you have to be careful. The negative is on the outside of x. It's not in the, there's not parentheses squaring the negative, right? Okay, so we have a negative on the outside. We're plugging in 2 squared plus 4 times 2 minus 2. So then make sure you don't put in the negative and then square it. This had a negative on the outside, right? If we would have been plugging in negative 2 though, it would become positive, right? Okay, 2 squared is 4. But it's negative 4 due to that negative, and then we have plus 8 minus 2. So that is 2. So our vertex is at 2, comma 2. So I'm going to plot that over 2 of 2. There's my vertex. Smiley face or frowny face? Frowny face, because our a value is negative. Very good. Third step, plot the y-intercept. It's always when x is equal to 0. So what's it going to be?
Negative 2.
So it's at 0, our y-intercept crossing the y-axis at 0, negative 2. So over 0, down 2. It's crossing the y-axis right there. Now I need 2 other points. You tell me 2 other points. We're going much quicker. 2 other points. 1, comma 1. So over 1, up 1. Awesome. Another one. 2, comma 2. Okay, so over 2, up. Oh, that's our vertex, right? So one more. 3, 1. Okay, so over 3, up 1. Okay, good. So now look, this point maps across the axis of symmetry to here. So we're good. This point's going to map across the axis of symmetry, so 1, 2, 1, 2. Does everybody see how to plot that? All right, we're almost done. Domain and range. Domain. All real numbers. Range. Where's my lowest point? Negative infinity, up to? 2, including 2. Are we all good? Are you ready to practice on your own?
Yeah.
All of those steps very carefully. Do 10 through 15. So you're skipping the first few to go to 10 through 15. Okay, so I've had a lot of people say, well, once again, how do you find the y-intercept? So hopefully this will kind of help you remember. So So remember, y-intercept is where it's crossing the y-axis, right?
Right.
So let's look at our graph. X, y, right? Isn't it always going to cross the y-axis somewhere on here?
Yeah.
And isn't that always the x value of 0, right? Look at the x values. Isn't that always 0 for x? Does that make sense, everybody? So to find that, you'll always plug in 0 for x. So once again, to find the y-intercept, that's always when x is equal to 0, right? Once again. So you plug in 0 into your function, and whatever you get out, it would be how high up or down it goes. Does that make sense, everybody? Problem number 2. Okay, so read the directions with me. It says, find the equation of the axis of symmetry and the coordinates of the vertex of the graph of each function. So we're just doing the first 2 steps of what we've just done for graphing, right? Finding the axis of symmetry, finding the vertex. But we don't need to graph it. So we're literally finding the axis of symmetry, finding the vertex. You should all be looking up here. What's my A value? What's my B value? And my C value? So to find the axis of symmetry, we use the formula x equals the opposite of B over 2 times A. Plug it in. The opposite of B will be opposite of positive 4, which is negative 4, over 2 times A. A is negative 1. So we're going to have negative 4 divided by negative 2, which is 2. So our axis of symmetry is x is equal to 2. Now to find the vertex, we're literally just doing our second step on our steps to graphing. So how do we find, if we know it's at the x value 2, how do we find y? Plug it in. So we have negative. That negative is not with the x, right? It's not going to be inside our parentheses. So negative 2 squared plus 4 times 2 minus 6. So we'll have negative 4 plus 8 minus 6. So we get negative 2. So our vertex is a point. It's 2, comma, negative 2. So second answer. And we're done with that. We're only doing the first 2 steps. Are we all okay with those? So you guys, the first page of this is due tomorrow. You've got to get it done. So you have homework. If you need to watch this video. So you have to do the whole front page.
All the front page?
The whole front page.